We've looked at a lot of different operators over the last 4 screencasts, but there are other ways that we can manipulate the results we get from a database besides using different operators in our query. So let's look at some of these in this screencast. First of all, the simplest thing we could do with results from a query is to count them. So let's say db.users.find where we'll say name.first is equal to John, because we know we have more than one of those. And then we can just say .count. And if we do that, you can see that we have the number 2 returned to us. Now, this is actually the longhand way of doing it. There's a shorter way of doing it, which is just db.users.count, and then we pass the query directly to that count method. So we can say John, just like that, and as you can see, we can get 2 returned to us as well. Now, since you know that we can say db.users.find with nothing in it to return all of the documents in that collection, you might think that we could do db.users.count to figure out how many documents are in that collection, and you'd be right. We can do db.users.count to find out that we have 4 users. Let's do db.links.count to find out that we have 12 documents in our links collection. Now, the next most useful thing, I think, would be sorting. We're going to find all of our links, but we're not going to get them all. We're just going to get their titles to start with, and we're actually going to exclude that ID. So if we do that, you can see that we just get all of our different titles listed, and this is what's called natural order. This is the order that they were put into the database in. So as you can see here, the link for NetTuts was put in first, the link for Graphic River was put in last. Now, if instead I say .sort, and I'm going to pass it an object, and I want to sort by the title, and I want to sort in ascending order, so I'm going to pass 1 to title, just like that. So let me clear the screen, and now if I run this query, you can see that they're now sorted in ascending order, which means they're sorted alphabetically. We can see them going from A, Amazon, all the way down to W, Wikipedia. Now let's go ahead and do a little bit more of a complex sort. We can add the favorites here and say we want to sort by favorites instead, and we want to sort by -1 here. We want to sort in descending order. As you can see, when we do this, that means we start with 654 favorites and we work our way down to 79 favorites. So descending order, -1, is the reverse, of course, of ascending order, which is the positive value of 1. Now, we can do more complex sorting than this. Notice that since we're sorting by favorites right now, our 2 documents that have the same number of favorites, 100, are right beside each other, but currently they're still sorted in natural order. Now, let's say that where the favorites are the same, we want to sort alphabetically. So what we can do to do that is add another field here to this object that we passed to sort, and we can say title is 1. And if I go ahead and clear the screen and run this, you can see that now our 2 different documents that have 100 favorites are sorted alphabetically, Audible audiobooks first and NetTuts second. Now, next up is the limit method. The limit method simply allows us to define exactly how many documents we want returned from the database. And if we combine limit with sort, we can actually use this to find the minimum and maximum values for a given field within our documents. So if I say db.links.find, we want to just find everything from those, but we're only going to return the title and the favorites, and we will exclude the ID. Let's tell it that we want to sort it by favorites, and I'll sort in ascending order first, so that we'll have our lowest value at the top, and then I'm going to say limit that to 1. And if we do that, you can see that we are returned the document that has the least number of favorites, our minimum favorites document. Now if we change the sort order to -1 so that we are in descending order with the maximum value at the top, we can see that the theme forest is the most popular link in our database. So that's how you can combine sort and limit to get the minimum and maximum values. Now, of course, we can use limit to get any number of items from our database. We can say db.links.find everything, and we're going to limit that to only 2. And as you can see, if we do this, and let's just for each print JSON to make it easier to see, we just get the first 2 documents that were inserted into our collection. That would be NetTuts and PSDTuts. And that's neat, and it makes sense using limit that way, but there's another case where limit is actually very, very useful, and that is in paging. Say we are doing a search results, or the viewer is viewing a certain catalog of, say, products, for example. You want to show them a certain number per page, and then you want to have next and previous page buttons at the bottom or at the top. So for example, in our case, let's say we want to have 3 links per page. We would obviously want to use limit to limit the number of results returned for each page request. However, we can't just always get the first 3 documents for every page. We want to use the skip method in combination with the limit method to make the effect of paging in our database. So we'll say db.links.findEverything. We're going to find everything, but the only thing we want returned is the title in this case. So now what we want to say is skip, and for the first one, I'm going to set it to 0 times 3. Now, obviously, this value will come from your programming in some way, but since I'm hard coding it in, I'm going to say 0 times 3. And this, of course, will be 0, which means we want to skip 0 documents at the first page. And then, of course, we're going to limit this to 3 documents a page. So if we do that, you can see we get nettuts, PSD tuts, premium tuts. These are the documents that would show on our first page. Now, let's say the user clicks the next page button. What would our query look like then? Well, to do that, all we need to do is say we want to skip the documents that are on page 1. So we change that value in skip to 1. And now we're going to skip the first 3 documents. Starting from document 4, we're going to limit it to 3 documents. So we get documents 4, 5, and 6. Envato, MongoDB, and Audible. Now we want to go to page 3. So we want to skip everything from page 2 and before. And we get those 3. Now on page 4, we would get those 3. And on page 5, well, we don't have anything left in the database. So now there's nothing to return when we skip our first 12 documents. So that's how we could implement paging using the skip and the limit functions. And really, that's pretty much everything you need to know about querying collections in MongoDB. We've looked at pretty much all of the operators that MongoDB offers. We've looked at different syntaxes. We've looked at grouping, getting distinct values. And now we've looked at manipulating our collection after they're returned to us. Now we're ready to move on to something a little bit more advanced, and that is updating documents. So we'll talk about that in the next screencast.